So today we learn about exponents. So an exponent is just a simplified form of multiplying a value numerous times. So for example, if I wanted to multiply 2 by 2 by 2 by 2 by 2. Now if I solve this, I'll get 4, then I'll get 8, then I'll get 16, then I'll get 32. So my final answer would be 32. Now let's say if right now I'm multiplying 2 by itself 5 times, right? 2 is multiplied by itself. Five times. What if we had to do this 100 times? Would I be able to write that? That's a lot of 2's. And right now, I'm getting tired of writing this. So I put a dot, dot, dot till I reach the last dot of last times of 2. So a simplified form or a method of writing a multiplication question of this sort is to use exponents. Now how do we utilize it? We'll write our number, whatever number we want to multiply. We call this the base. And we'll write the number of times we want this number to multiply by itself up here. So if I wanted 100, this is called our exponent. It's called our power. It's called the index. There are numerous terms for it. But in the algebra 1 or geometry syllabus, we'll be using the term exponent more than the other ones. But familiarity with the other terms will be crucial. So 2 exponent 100. Now in your calculator, there are various ways to represent exponents. So some calculators use this notation, which is also in your keyboard. So a calculator or your computer keyboard will be using this. So if I wanted to write 2 exponent 3, I would just write it this way, or I would write it this way, or I would write it this way. Another way the calculators might use another function. So this would be a function tab on your screen. Some calculators might use xy or yx. So this represents exponent. So this just means 2 multiplied by itself 3 times. So we get 8. So in our calculator T84 plus CE, we'll find the exponent symbol right here. So you see this caret right here. And then you have an x squared over here if you were to look at that. So that's only for squares. So if you want values like 17 squared, you could use 17 and then press this x squared button. So you'll end up getting 189. But if you needed 2 exponent 62, I would use this symbol. Okay, so this is how you'll use the two functions. Now there are certain rules associated with exponents. So laws of exponents. Let's try the first one. So if we have 2 squared times 2 cubed. So now what is 2 squared? 2 squared is 2 times 2. What is 2 cubed? 2 times 2 times 2. Now how many times have we multiplied 2 by itself? So we have 1, 2, 3, 4, 5. So 2 is multiplied by itself 5 times. What is the product? 4, 8, 16, 32. So 2 exponent 5. Sorry, this should be 32. 2 exponent 5 is also 32. So you see the relationship, 2 exponent 5 is 32, or it's also 2 squared times 2 cubed. So let's generalize the rule. So when we see this multiplication, now we are looking at common features. So whenever we see this multiplication sign and we see the same base, we will add these exponents, add exponents. So basically, if I have 2 squared times 2 cubed, and if I add these two exponents, I'll end up getting 2 exponent 5, which is the same as this answer. So this is called our multiplication or product rule. So basically, if you see two exponents multiplying, we can add the exponents. Now let's try the next one, the quotient rule or the quotient law. So if you recall, quotient means division. So if you have 2 cubed divided by 2 squared, so we write this 3 times and we'll write this twice. And remember that idea is I showed previously that you can always cancel if you see the same number in the numerator and denominator. So what are we left with? Just one of the twos. So in the quotient rule, if you see an exponent, you subtract the two values and you'll get the final answer. So in algebraic form, we'll write all the rules in algebraic form once we are done. Then we have the power rule or the power law. So if you have 3 squared exponent 3, so here we multiply these two values. So we'll get 3, 2 times 3, which becomes 3 exponent 6. And then we can solve that as 729 using a calculator. So how did we get this? So let's take this blue box, right? I'm going to put it in a red box. So now we've got this red box and we have an exponent of 3. So what we are saying is let's repeat this red box 3 times. And now what's in that red box? It's 3 squared, 3 squared, 3 squared, 3 squared. Now let's solve the red boxes. So what's 9 times 9 times 9? 729. So this is the power rule. If you see a power of a power, you'll multiply the two powers, and that's how you'll get your answer. And then you have common exponents. So we have common exponents. So for example, 3 squared times 2 squared. So you see the exponent is the same. What we can do in this case is we can simplify the expression this way and keep the common exponent as an exponent outside. So we'll get 6 squared, which will resolve as 36. Let's say when we solve these values individually, do we get the same thing? What's 3 squared? 9. What's 2 squared? 4. What's 9 times 4? Is it 36? So we can approach this question in so many ways. Like here there are like 5 steps, 5 different ways to get your answer. Similarly, when you're dividing, you can write it this way. 3 divided by 2 is 1.5. The square of 1.5 is 2.25. Similarly, if you solve this, you'll get 9 divided by 4. That resolves or solves to 2.25. Then we have the exponent of 0. So what if you have 2 squared divided by 2 squared? Now we learned with the quotient rule we can subtract the exponent, so we get 2 exponent 0. Now if we look at the numerical value, we'll get 4 divided by 4, which gives us 1. These two become the same, so the exponential value of 0 always solves to 1. So next we have negative exponents. So what if we have 2 squared and 2 exponent 4 at the bottom? So as per the quotient rule, we can subtract the exponents. So this is what we get. 2 exponent negative 2. But if we were to write these values out, so let's just express them numerically. What's 2 squared? 4. What's 2 exponent 4? That's 16. Now if you simplify 4 16th, you end up getting 1/4, right? Or if we wrote this expression this way, we can cancel these off. So what are we left with? 1 divided by 2 squared. So all of these are relevant expressions. So 2 exponent negative 2 is also 1 divided by 2 squared, and it's also 1 divided by 4. All of these are the same, representing the same thing. So if you have a negative exponent, you can always write it as a positive exponent in this manner. Lastly, if we have a fractional exponent, so if we had 3 exponent half, this translates to being the square root of 3. Similarly, if you have 3 1/3, this translates as the cube root. So this is the square root. This is the cube root. And then if you have the 4th root, you would write it this way. And all of this can be found on your calculator. So if you went to math, is where you would find you can find all the tools on your calculator. So if you went to math, right here, this math will get you to this menu, and then you can choose this for cube root, this for cube, and if you have the xth root, Like if you have the fourth root or the fifth root and so on. If you have the square root, even you can use that and plug in square root, but there's an easy way to do square roots right here. So you see this blue line over here. You see this, that's your square root, which you can easily apply. Okay, so if we wrote everything algebraically, we would get these expressions. This is what you want to remember. So a exponent x. This a is called your base. The x is called your exponent or your power or your index. Multiplication law. If you have two exponents that are multiplying, add exponents. So you end up getting m plus n. Quotient law. If you have two exponents that are dividing, subtract exponent. So you get a m minus n. If you have the power law, a exponent n, parentheses n, multiply. So you end up getting mn or n times n. And then if you have something like this, you can take the exponent common and solve. Similarly, if you have the same thing in division, this is called the common power. You'll get this. And then if you have zero exponent, okay, that is always equal to 1. And then you have negative exponent. That is always equal to the reciprocal. So this expression is the reciprocal. So if you have a fraction 1/2, the reciprocal is 2 divided by 1. If you have an expression 2/3, the reciprocal is 3/2. So you're flipping, you're making the numerator the denominator and the denominator the numerator. And then lastly, if we have a fractional exponent, we'll write it as the square root. So these are the rules of exponents you need to know. Good luck.